Are you struggling with percent composition? Well, it's your lucky day. In this video, we will go through how to solve for percent composition. Percent composition is essentially the percent of every element in a compound by mass. Now, to solve for percent composition, you take the total mass of an element and divide it by the total molar mass of a compound or molecule and multiply it by 100. Let's see this in action. Our first example, water, has the molecular formula of H2O. To begin, we need to find the mass of each element, which we can find on the periodic table. We can see here that oxygen is 16 atomic mass units and hydrogen is 1.01 AMU. Now, let's find the total mass of the compound. To do this, we count the number of each type of element in a single molecule. Looking back at the equation for water, we can see that there are 2 hydrogen atoms and 1 oxygen atom. This means that to find the total mass of the compound, we must multiply the atomic mass of hydrogen by 2 and oxygen by 1. The total for hydrogen would be 2.02 AMU, and the total for oxygen would be just 16 AMU. The total atomic mass of the molecule would be the sum of 16 and 2.02, which would equal 18.02 AMU. Now, to find the percent composition of oxygen, we must take the total atomic mass of oxygen, which we just found, and divide it by the total mass of the molecule, which we previously calculated as 18.02 AMU. We must then multiply all of this by 100. The mass percent of oxygen is 88.79%. We must do this for every single element in the molecule, so we are going to repeat this process for hydrogen. Repeating the same process for hydrogen, we divide 2.02 by 18.02 and multiply it by 100 to get a mass percent of 11.21% for oxygen. Our next example, a little more complex than water, is iron 2-phosphate. This has the molecular formula of Fe3PO4 2. Remember that our first step is to find the atomic mass of each element, which is located on the periodic table. Iron is 55.85 AMU, phosphorus is 30.97 AMU, and oxygen is 16 AMU. Now, to find the total mass of the compound, we must find the number of each element in a single molecule. Remember that the polyatomic ion in the parentheses is multiplied by the subscript outside of the parentheses. We can see that there's 3 iron atoms, 2 phosphorus atoms, and 8 oxygen atoms. Now we're going to go through the exact same steps as the previous example. To find the total mass of the molecule, we must add up the total masses of each element. This comes out to be 357.50 AMU. As a final reminder, you can check your answers by adding up all the percent compositions of each element, which should total to 100%. However, there could be a small amount of error due to rounding differences. That's it. Thanks for watching.